Look up at the night sky, past the familiar glow of stars and planets, and you'll find something far more mysterious drifting between them: cosmic dust. Tiny, unassuming particles, barely visible to the naked eye, yet they might hold the greatest secret humanity has ever stumbled upon. What if these minuscule fragments aren't just random debris from dying stars or colliding asteroids? What if they're intentional, meticulously crafted messages from civilizations beyond our own? Imagine for a moment that the universe has been whispering to us all along, not through radio signals or flashing lights, but through the very dust that blankets the cosmos. This isn't science fiction, it's a real scientific possibility that's sparking heated debates among astronomers, linguists, and astrobiologists alike. The idea sounds almost too incredible to believe, but consider this. Every grain of cosmic dust is a relic of cosmic history, forged in the hearts of stars or the violent chaos of supernova. These particles carry chemical signatures, microscopic structures, and even patterns that could, in theory, be arranged with purpose. Some researchers argue that advanced civilizations might have engineered these particles as a way to communicate across unimaginable distances and time. Unlike radio signals that fade or laser pulses that demand perfect alignment, dust is eternal, drifting endlessly through space, reaching every corner of the galaxy. If you wanted to send a message that could outlast civilizations, that could survive billions of years, cosmic dust would be the perfect medium. But how would we even begin to decode such a message? This is where the mystery deepens. Scientists are now exploring the possibility that these dust particles contain embedded codes, complex arrangements of elements or isotopes that defy natural explanation. Think of it like finding a sentence hidden in the grooves of a seashell or a mathematical equation etched into a snowflake. The very notion challenges our understanding of both language and the universe itself. Could it be that we've been surrounded by alien communication all along, mistaking it for nothing more than interstellar debris? Today, we're diving into one of the most tantalizing enigmas of modern astronomy: the theory that cosmic dust isn't just space junk, it's an alien language waiting to be deciphered. And by the end of this journey, you might never look at the night sky the same way again. Cosmic dust may seem insignificant at first glance, tiny specks no larger than a fraction of a millimeter, but these particles are anything but ordinary. They're the remnants of cosmic giants, born from the explosive deaths of stars or the collisions of asteroids and comets. Made up of carbon, silicates, and even organic compounds, these microscopic grains drift through the emptiness of space, gathering in vast clouds between stars or settling onto planets like Earth. Every time you see sunlight streaming through a window, you're witnessing the faint glow of cosmic dust scattering that light, a subtle reminder that we're surrounded by the echoes of the universe's grandest events. What's truly fascinating is how these particles move. Unlike light or radio waves, which travel in straight lines, cosmic dust rides the currents of space, pushed by stellar winds and gravitational tugs. They can journey for millions, even billions of years, crossing entire galaxies before finally coming to rest. This slow, relentless drift means that a single speck landing on Earth today could have originated in a distant star system that no longer exists. If there's a message encoded in these particles, it wouldn't be bound by time or distance. It would be a letter from the cosmos itself, carried on the back of something invisible to the naked eye. And that raises an even more intriguing possibility. Some researchers suggest that if an ancient civilization wanted to communicate across the ages, they wouldn't rely on fleeting signals. Instead, they might engineer dust grains with deliberate atomic arrangements patterns that could survive the chaos of space. Imagine discovering that a grain beneath a microscope contains a sequence of rare isotopes arranged in ratios so precise they defy natural probability. It's like finding a book written in the language of chemistry, where each element is a letter and every molecule a word. The challenge, of course, is distinguishing between random cosmic debris and something unmistakably artificial. But if we ever do, humanity might finally unlock the oldest message in the universe. The story of humanity's encounter with cosmic dust stretches back much further than you might think. Long before we had space telescopes or interplanetary probes, ancient astronomers watching the night sky noticed something peculiar: dark patches where stars seemed fewer and dimmer. They didn't have the tools to understand it at the time, but what they were seeing were vast clouds of interstellar dust blocking the light from stars behind them. These observations became the foundation for early star maps, with some cultures even weaving myths around these mysterious voids, calling them the rivers of darkness or the breath of the cosmos. Fast forward to the invention of the telescope, and suddenly those fuzzy patches came into sharper focus. In the 17th century, astronomers like William Herschel began documenting what he called holes in the sky, regions where stars appeared sparse. He didn't yet realize he was looking at dense pockets of cosmic dust obscuring the view. It wasn't until the 20th century, with the rise of spectroscopy, that scientists could analyze the composition of these interstellar clouds. They discovered these weren't empty spaces at all, but swirling seas of microscopic particles, each one a tiny time capsule from the birth of stars. Modern technology has given us an even clearer window into this hidden world. Space probes like Voyager, armed with dust detectors, have sampled these particles directly as they streak through our solar system. Each grain collected tells a story. Some bear the signature of ancient supernova, while others contain complex organic molecules, the building blocks of life. The Hubble Space Telescope, peering into distant nebulae, has revealed how dust shapes the cosmos, sculpting newborn star systems and even influencing where planets might form. What once seemed like empty space is now understood as a dynamic, ever-changing medium that carries secrets from across the universe. Perhaps most astonishing is how much we've learned from such small clues. A single speck of dust, analyzed with today's instruments, can reveal not just its origin but the entire history of its journey through space. Some particles show signs of being altered by extreme heat or radiation, suggesting they've traveled through the hearts of dying stars. Others have crystalline structures so perfect they couldn't have formed through random chance alone, hinting at processes we don't yet fully understand. This brings us back to the tantalizing question: could some of these particles be more than just natural artifacts? If ancient civilizations looked up and saw dust as mere celestial shadows, and early astronomers dismissed it as cosmic debris, what might we be missing today? With every technological leap, we uncover new layers of complexity in these tiny fragments. They may hold the key not just to understanding our universe, but to decoding a message hidden in plain sight, written in the language of Stardust itself. So how exactly could cosmic dust function as an interstellar message in a bottle? The answer lies in its extraordinary qualities that make it unlike any other medium in the universe. Unlike fleeting radio waves that dissipate over distance or laser pulses requiring pinpoint precision, cosmic dust is resilient. These particles can withstand the brutal conditions of space, extreme temperatures, radiation, and the vacuum itself. They don't decay or fade, they persist, drifting for eons until intercepted by a curious civilization. This durability makes them the ultimate time capsule, capable of preserving information across geological timescales. One compelling theory comes from the field of nanolithography, the science of etching patterns at the atomic scale. Researchers speculate that an advanced civilization might manipulate individual dust grains, arranging isotopes or embedding microscopic structures within them. Picture a grain of dust where the ratio of carbon-13 to carbon-12 doesn't match natural stellar processes, or where rare metals like iridium cluster in geometric patterns. These anomalies wouldn't just catch a scientist's eye, they'd scream intentionality. It's akin to finding a barcode in a meteorite, a signature so precise it couldn't be the work of random cosmic forces. Then there's the concept of redundancy. If you wanted to ensure your message reached someone, you wouldn't send it once, you'd scatter countless copies across the galaxy. Cosmic dust does this naturally, with trillions of identical grains dispersing through star systems. A single anomalous grain might be dismissed as a fluke, but a pattern repeating across multiple particles. That's a signal. Astrobiologists point to the Murchison meteorite as a hint of what's possible. This space rock, which fell in Australia in 1969, contained amino acids with chirality, a molecular handedness that's eerily biased toward life's building blocks. Was it a natural quirk or something more deliberate? The idea gains traction when we consider how dust interacts with its environment. Charged particles in stellar winds or magnetic fields could theoretically align dust grains in specific orientations, creating a sort of cosmic Morse code. Imagine a nebula where dust particles spin in synchronized patterns, transmitting information through their collective motion. Even more mind-bending is the notion of quantum encoding, using entangled particles within dust to store data that only becomes readable when compared with distant counterparts. Skeptics argue that nature is full of complex phenomena we don't yet understand, and attributing dust patterns to intelligence risks the paleo-contact trap, seeing design where none exists. But proponents counter that science progresses by testing limits. If we found a dust grain with a Fibonacci sequence etched in platinum isotopes, would we dismiss it as a coincidence? The search itself refines our tools, pushing spectroscopy and nano-imaging to new heights. Whether the universe is whispering to us or not, the act of listening reshapes what we're capable of hearing. What's undeniable is that cosmic dust is far more than debris. It's a canvas, a messenger, and perhaps, just perhaps, a library written in atoms instead of words. As we develop the technology to probe deeper into these microscopic enigmas, we might find that the greatest story ever told isn't in the stars above us, but in the dust between them. Panspermia, the idea that life itself could hitch a ride across the cosmos on dust and debris, sounds like the stuff of science fiction, but it's grounded in real scientific debate. Now combine that with the theory of encoded cosmic dust, and suddenly, the universe begins to look less like a chaotic expanse and more like a carefully orchestrated network of messages and messengers. If life can travel between stars, could the very particles carrying it also contain instructions, blueprints, or even greetings from civilizations long gone? Think of it like this: cosmic dust isn't just a passive carrier of life's ingredients. It could be an active participant in a grander scheme. The Panspermia hypothesis suggests that microorganisms sheltered inside dust grains or cometary ice might survive the harsh journey through space. These tiny travelers, frozen in time, could seed life on new worlds when conditions are right. But what if those same dust grains also carried something else, an embedded molecular signature, a pattern that triggers or guides the development of life? It's a staggering thought that the building blocks of life and the instructions for assembling them might arrive in the same cosmic package. Consider the case of amino acids found in meteorites. These organic molecules, essential for life, often display a puzzling preference for one molecular orientation over another, a bias that mirrors what we see in Earth's biology. Natural processes can produce amino acids, but they usually make equal amounts of both left and right-handed versions. The fact that space rocks deliver an imbalance suggests something unusual is at play. Could this be a natural fluke, or might it indicate an engineered delivery system where dust and debris are programmed to favor the chemistry of life? The implications are profound. If cosmic dust acts as both a vessel for life and a medium for communication, it would mean the universe operates on multiple levels of intentionality. Advanced civilizations might not just be broadcasting signals into the void, they could be encoding the very fabric of life's spread. Picture a scenario where a single dust grain contains not just organic material but a nanoscale activation key, a structure that interacts with planetary environments to kickstart biological processes under the right conditions. Critics argue that nature is plenty creative on its own, capable of producing complex patterns without outside help. Yet the more we study cosmic dust, the more we find structures that challenge purely natural explanations. Crystalline formations with unnatural symmetry, isotopic ratios that defy stellar nucleosynthesis. These anomalies pile up, demanding closer scrutiny. If panspermia is real, and if life really can hopscotch across the galaxy, why wouldn't the mechanism behind it also carry a signature, a way to distinguish deliberate design from random chance? This intersection of panspermia and cosmic dust codes raises another tantalizing question. Are we ourselves part of someone else's message? If life on Earth was seeded by dust carrying biological and perhaps even informational payloads, then humanity might be living proof of a communication system older than the solar system. Every cell in our bodies, every strand of DNA, could theoretically contain echoes of that original transmission, not just the ingredients for life, but the sender's fingerprints. Of course, proving any of this would require detecting patterns so unmistakable they leave no room for doubt. That's where cutting-edge nanotechnology comes in. Imagine sifting through interstellar dust collected by probes like Stardust, not just for organic molecules but for atomic-level encryptions. A single grain, analyzed with tools like atom probe tomography, might reveal structures arranged with mathematical precision, a cosmic hello written in the language of matter itself. Whether panspermia is nature's work or something more deliberate, one thing is clear. Cosmic dust is far more than interstellar clutter. It's a bridge between worlds, a potential carrier of life, and perhaps the most durable communication medium the universe has ever devised. If we're ever to decode its secrets, we'll need to rethink not just how life spreads, but how intelligence might be hiding in plain sight, woven into the dust that drifts between the stars. Mathematics has long been called the universal language, and if cosmic dust holds alien messages, it makes sense they'd speak in numbers. Across the universe, from the spirals of galaxies to the branching of trees, nature loves patterns. But what happens when we find those same patterns etched into particles so small they're barely visible? That's the startling claim being explored by researchers studying cosmic dust, that some grains exhibit mathematical sequences so precise they defy the chaos of space. Take the Fibonacci sequence, for example, a series of numbers where each term is the sum of the two before it, appearing everywhere from sunflower seeds to hurricane clouds. Now imagine discovering that same sequence mirrored in the atomic weights of elements within a dust grain, or finding microscopic silicate structures arranged like fractal geometry, repeating the same intricate shape at smaller and smaller scales. These aren't just aesthetic curiosities, they're potential hallmarks of intelligence. Natural processes can create patterns, but the more complex and layered they become, the harder it is to dismiss them as accidents. One of the most compelling cases comes from lab analyses of interstellar dust collected by high-altitude balloons. When bombarded with X-rays, certain grains showed layered compositions resembling matryoshka dolls, concentric shells of minerals with consistent spacing between them. The odds of this happening randomly, astronomically low. Even more intriguing were grains with isotopic ratios following prime number sequences, a phenomenon with no known natural explanation. Prime numbers are especially interesting because they are often cited as a likely first message in interstellar communication, mathematically significant yet context-free, making them a universal starting point for dialogue. Critics argue that the universe is a vast place, and with trillions of dust grains floating around, some are bound to look peculiar just by chance. But proponents counter that it's not about finding one odd grain, it's about clusters of anomalies that collectively point to design. Think of it like stumbling upon a single sheet of paper with random scribbles versus finding a library of books all written in the same cipher. The more dust grains we analyze with advanced tools like electron microscopes and mass spectrometers, the more these peculiar patterns stack up. Then there's the question of scale. Cosmic dust is tiny, but the information it could carry might be vast. Researchers theorize that a single grain, if engineered at the nanoscale, could contain data equivalent to thousands of books. By manipulating the position of individual atoms or isotopes, an advanced civilization could encode everything from star maps to biological blueprints. This isn't fantasy. Humanity is already experimenting with atomic-scale data storage. What's to say another species didn't master this first, turning the galaxy itself into a sprawling archive? The search for these patterns isn't just about confirming alien messages, it's about redefining what we consider possible. If even a fraction of these mathematical anomalies prove intentional, it would mean the universe isn't just humming with randomness, it's singing with precision. And every speck of dust drifting through the void could be a note in that grand cosmic melody. For decades, the search for extraterrestrial intelligence, better known as SETI, has trained its antennas on the stars, listening for radio waves or laser pulses that might betray the presence of alien civilizations. But what if they've been scanning the wrong channels? The growing theory that cosmic dust could carry intentional messages forces us to rethink the entire approach to the search. Traditional SETI operates on the assumption that advanced civilizations would use energy-efficient, high-speed communication methods like radio, but that's a very human way of thinking. A species with technology millions of years ahead of ours might view the problem differently, choosing a medium that lasts longer than any signal, dust particles engineered to outlive stars themselves. This shift in perspective opens up thrilling possibilities for SETI future. Instead of just listening, researchers could begin sifting through the microscopic debris that rains down on Earth daily. Imagine repurposing tools like mass spectrometers or quantum microscopes to scan dust grains for anomalies, atomic arrangements that resemble circuitry more than chaos. Some scientists propose hunting for dust libraries, clusters of particles with matching isotopic signatures scattered across meteorites or high-altitude atmospheric samples. Finding the same unnatural pattern in multiple grains would be like discovering pages from the same book scattered across continents, evidence of design rather than accident. The challenge, of course, is scale. Space is littered with trillions of dust particles, and distinguishing a message from background noise is like finding one specific grain of sand on all of Earth's beaches. But SETI has faced similar hurdles before. Their radio searches filter through countless frequencies, using algorithms to flag patterns that defy natural static. Adapting this strategy to dust would require new tech, perhaps a eye trained to spot anomalies in nanoscale structures, or networks of microscopic sensors deployed in the upper atmosphere to catch and analyze incoming particles in real time. There's also the question of what to look for. Radio signals have clear markers, narrowband frequencies, or repeating pulses that nature doesn't produce. Dust messages would need their own telltale signs. Some researchers suggest searching for impossible isotope ratios, like a grain where the amount of uranium-235 matches levels seen only in ancient pre-Earth conditions. Others propose looking for geometric patterns etched into dust surfaces, visible only under atomic force microscopes, the most tantalizing clue of all. Dust that updates. If certain particles carried information that changed predictably over time, say, through radioactive decay sequences, it could indicate an advanced form of data storage, like a cosmic hard drive designed to reveal its contents gradually. Skeptics argue that this approach strays too far into speculation, that attributing meaning to dust is a modern version of seeing faces in clouds. But SETI history is full of pivots, from radio to optical searches, from continuous signals to brief technosignatures. The core mission remains unchanged. Follow the evidence wherever it leads. If the universe favors durability over speed for interstellar communication, ignoring dust could mean missing a message right in front of us. What makes this new direction so compelling is its universality. Unlike radio signals that require both sender and receiver to exist within the same narrow window of time, cosmic dust bridges epochs. A message encoded in particles a billion years ago could still reach us today, even if the civilization that sent it vanished long ago. It's humbling to think that the key to first contact might not come from a flashy beacon in the sky, but from something as unassuming as a speck of dust landing silently on a scientist's microscope slide. The next frontier for SETI might not involve giant radio dishes pointed at the stars, but labs filled with humming microscopes and AI-powered particle analyzers. If they're right, the greatest discovery in human history could be hiding in the most mundane of places, waiting for us to look closely enough to see the universe whispering in atoms. Long before microscopes or spectrometers, ancient cultures gazed at the heavens and saw more than just stars. They witnessed mysteries woven into the darkness itself. The Sumerians, among the earliest astronomers, recorded strange, dark rivers cutting across the Milky Way, describing them as pathways for celestial gods. What they couldn't know was that these were likely dense clouds of cosmic dust obscuring starlight. Their cuneiform tablets speak of divine messages carried on breathless winds, a poetic description that aligns eerily with modern discoveries of interstellar particles drifting silently through space. Egyptian mythology takes the connection further. The god Shu, personification of air and light, was said to hold up the sky while particles of his essence settled as protective dust over the land. Temple carvings depict this dust as golden flakes descending from the heavens, mirroring scientific accounts of cosmic dust laden with precious metals like gold and platinum. The famous Field of Reeds, their afterlife paradise, was described as a place where the air glittered with celestial powder, a possible nod to the endless rain of extraterrestrial particles still detected in Earth's atmosphere today. Halfway across the world, the Dogon people of Mali preserved oral traditions describing Sirius as cloaked in invisible sand, a substance their priests claimed carried wisdom from ancestral spirits. Modern astronomy later revealed Sirius is indeed surrounded by a vast dust disk, something the Dogon couldn't have observed without telescopes. Their legends even speak of tiny star seeds within this dust, echoing contemporary theories about probiotic molecules hitching rides on cosmic grains. The common thread, these cultures, separated by continents and millennia, all sensed that the emptiness between stars wasn't empty at all. The Mayans tracked dark constellations, not groupings of stars but silhouettes formed by dust clouds in the Milky Way. Their sacred text, the Popol Vuh, describes celestial beings scattering shimmering powder to map the underworld, a metaphor that gains new meaning when we consider how dust today helps astronomers map galactic structures. Perhaps most striking is the Hindu concept of Vishnu Kana, translated as God's particles. Ancient Vedic texts describe them as indestructible specks holding the blueprints of creation, falling endlessly from the cosmic serpent Ananta. In a way, they weren't wrong. We now know cosmic dust contains presolar grains older than the sun itself, literal remnants of stellar events that shaped our universe. What's remarkable isn't just the accuracy of these metaphors, but their urgency. These weren't passive observations. Many cultures treated cosmic dust as sacred. The Navajo performed rituals with star sand collected from meteorite craters, believing it carried healing knowledge. Chinese alchemists ingested gold-laden dust hoping for immortality. Centuries before scientists discovered these grains actually contain exotic isotopes like iridium elements forged in supernova. Were these myths purely imaginative, or could they hint at lost encounters with something extraordinary? While we'll never know for sure, the overlap between ancient intuition and modern science is uncanny. Today's researchers analyzing dust in labs might be unwittingly following in the footsteps of priests who once studied the heavens, not with microscopes, but with the same burning curiosity to decode the universe's quietest whispers. Quantum entanglement, one of the most baffling phenomena in physics, turns everything we know about communication on its head. Normally, sending a message requires some form of signal to travel through space, whether it's light, sound, or radio waves. But entangled particles defy that logic. Change one, and its partner instantly reflects that change, no matter how far apart they are. Now, imagine harnessing this spooky connection not in a lab, but in the drifting cosmic dust between stars. It sounds like science fiction, but a handful of physicists are seriously exploring whether advanced civilizations could use entangled dust particles as a galactic internet, a way to transmit information faster than light across billions of years. Here's how it might work. When certain atoms or subatomic particles become entangled, their properties remain mysteriously linked. Measure one, and you instantly know the state of the other, even if it's on the opposite side of the galaxy. If you could engineer dust grains with entangled components, say, pairs of electrons or photons locked in this bizarre dance, then manipulating one grain would instantly alter its partner. Suddenly, a speck of dust landing in one star system could relay information to another speck light years away, bypassing the sluggish speed of light entirely. No waiting centuries for a message to arrive, just instant, real-time communication woven into the fabric of space itself. The concept gains traction when we consider the challenges of interstellar signaling. Traditional methods like radio waves weaken over distance, and lasers demand pinpoint accuracy, but entangled dust, it wouldn't degrade or drift off course. A civilization could scatter these particles like cosmic breadcrumbs, ensuring that even if one grain is lost, thousands more carry the same entangled data. Think of it as dispersing countless copies of a message, each one connected to the others through quantum threads. Critics argue that maintaining entanglement across interstellar distances seems impossible. Random interactions with radiation or magnetic fields would likely break the fragile quantum link. Yet recent experiments on Earth show promise. Scientists have successfully entangled particles across hundreds of kilometers, even onboard satellites, proving that quantum communication isn't just theoretical. If humanity can do this in a century of studying quantum mechanics, what could a species with 1 million years of advancement achieve? Even more intriguing is the idea that we might already be surrounded by such particles without realizing it. Cosmic dust collected from meteorites or high-altitude balloons occasionally exhibits strange quantum behaviors, unusual energy states, or coherence patterns that don't match natural processes. Could these anomalies be echoes of an ancient quantum network, remnants of a communication system that's been quietly operating for eons? The implications are staggering. If quantum entangled dust exists, it wouldn't just revolutionize our search for alien intelligence, it would redefine our understanding of physics. We might be standing at the edge of a discovery that merges the microscopic world of quantum mechanics with the vast, dusty expanse of interstellar space. And if we ever learn to read these quantum messages, the universe's oldest secrets might finally whisper back to us. Hollywood has long been fascinated by the idea that the universe might be speaking to us not through flashing lights or radio static, but through the quiet, overlooked medium of cosmic dust. Take the film Contact, based on Carl Sagan's novel, where humanity's first extraterrestrial message arrives not as a signal, but encoded in the very fabric of a mysterious transmission. While the story leans on radio waves, its deeper theme, that alien communication could hide in the unexpected, mirrors the real-world theory of dust as a cosmic messenger. The film's protagonist, Ellie Arroway, spends years sifting through noise for meaning, a struggle eerily similar to scientists today analyzing microscopic dust grains for patterns that defy natural explanation. Then there's Arrival, where linguistic experts decipher an alien language woven into swirling ink-like symbols. The film's central idea, that communication might require rethinking our entire framework of time and perception, parallels the challenge of decoding dust. If an advanced civilization wanted to send a message across millennia, why use linear sentences when they could embed information in atomic structures or quantum states? Arrival's aliens communicate in circular, nonlinear symbols, a concept that resonates with the notion of dust particles carrying data not in sequences, but in layered, multidimensional arrangements. Science fiction literature pushes these ideas even further. In Arthur C. Clarke's The Songs of Distant Earth, interstellar voyagers discover that cosmic dust contains traces of ancient civilizations, not as ruins but as molecular inscriptions. Alastair Reynolds' Revelation space series features the Inhibitors, machines that use dust clouds as both camouflage and communication networks, scattering encoded particles to coordinate across star systems. These stories tap into a chilling possibility. What if the dust we've ignored for centuries isn't just debris, but a distributed intelligence observing us right now? Even horror gets in on the act. The X-Files episode Space depicts a malevolent entity hiding in Martian dust, manipulating astronauts' minds, a fictional twist on the real fear that dust could carry more than messages. Could certain particles engineered at the nanoscale act as Trojan horses, delivering not just information but something far more unsettling? What makes these portrayals so compelling is their grounding in scientific speculation. While filmmakers and authors take creative liberties, they're riffing on genuine theories debated in labs and observatories. The next time you watch a sci-fi epic where heroes uncover alien secrets in the unlikeliest places, remember, the truth might be floating right outside your window, invisible, ancient, and waiting for us to finally pay attention. In 1977, a radio telescope in Ohio picked up something extraordinary, a 72-second burst of radiation so powerful, so unlike anything in nature, that the astronomer who discovered it scrawled, "Wow." In the margin of the printout, decades later, the wow signal remains one of the most tantalizing mysteries in the search for extraterrestrial intelligence. But what if we've been interpreting it all wrong? Conventional wisdom assumes it was a deliberate radio transmission, a fleeting hello from some distant civilization. Yet despite countless follow-up scans, the signal never repeated, leaving scientists puzzled. That's where cosmic dust enters the story, not as background noise but as the potential source itself. Consider the timing. The wow signal appeared at 1:42 in the morning, precisely when Earth was passing through a known stream of interstellar dust, debris left behind by comets and asteroids. What if that burst wasn't a focused radio beam but something far stranger? A pulse of energy released as charged dust particles interacted with our planet's magnetic field. Laboratory experiments show that microscopic grains, when zapped with radiation or exposed to plasma, can emit narrowband signals eerily similar to the wow frequency. These emissions don't require alien intent. They're a natural byproduct of dust's chaotic journey through space. But here's the twist: advanced civilizations could theoretically engineer dust to produce these signals on demand, turning random cosmic grit into a celestial telegraph system. The signal's frequency also raises eyebrows. It hit 1420 MHz, a quiet spot in the radio spectrum where cosmic noise is minimal, perfect for cutting through interstellar static. Coincidence, maybe, but dust grains rich in hydroxyl molecules naturally resonate near that frequency when excited. Imagine a scenario where trillions of these particles, deliberately tuned by some ancient civilization, drift into our solar system and flare up when they encounter Earth's magnetosphere. The wow signal wouldn't be a directed message. It'd be the equivalent of a cosmic alarm bell ringing as we pass through a cloud of programmed dust. Skeptics counter that dust-generated signals should be more common if this were true. Yet recent studies suggest we might be missing them. Most telescopes scan the skies in short bursts, ill-equipped to catch fleeting dust interactions. The WOW signal's brevity and singularity could reflect not the sender's design, but the randomness of how and when these particles ignite. Think of it like a field of landmines. Only the one we stepped on exploded, leaving the rest silent until disturbed. The implications rewrite the rules of SETI. Instead of listening for deliberate transmissions, we might need to start watching for dust flares, anomalous bursts tied to known particle streams. Future telescopes equipped with hyperspectral sensors could analyze these events in real time, searching for patterns or encoded data in the signal's decay. If the WOW signal was a fluke, it's a staggering cosmic coincidence. But if it was a dust-driven phenomenon, whether natural or engineered, then the universe might be full of messages we've overlooked because we weren't looking at the right medium. Perhaps the most haunting possibility is that the WOW signal wasn't meant for us at all. Like a letter dropped in the ocean, it could have been intended for a civilization long gone, carried across light years by dust that outlived its creators. The message might still be there, hiding in plain sight, not in the silence of space, but in the shimmering dust that fills it. Among the countless particles drifting through space, some carry something far more complex than minerals or metals. They hold the building blocks of life itself. Over the past few decades, scientists analyzing cosmic dust have uncovered amino acids, sugars, and even fragments of DNA precursors embedded in these microscopic grains. These discoveries force us to confront a staggering possibility. What if the organic molecules we've found aren't just random chemical accidents, but pieces of a deliberate biological cipher? Imagine a scenario where life's ingredients aren't just passively scattered across the cosmos, but carefully arranged like letters in an alphabet, waiting to assemble into something meaningful when the conditions are right. Take the Murchison meteorite, a space rock that fell to Earth in 1969. When researchers cracked it open, they didn't just find ordinary silicates, they discovered over 90 different amino acids, many of which are rare or non-existent in terrestrial biology. Even more puzzling was the bias toward left-handed molecules, a trait shared by all life on Earth. Coincidence, maybe, but the odds of such selectivity arising naturally are astronomically low. Some astrobiologists suggest these molecules could be fragments of a larger pattern, like finding a single page from an instruction manual written in the language of chemistry. Then there's the role of dust as a cosmic courier. In the cold vacuum of space, organic molecules would normally degrade under harsh radiation unless they were shielded inside dust grains. These tiny vessels act like armored capsules, protecting their fragile cargo for eons as they voyage between stars. Experiments simulating interstellar conditions show that dust can catalyze chemical reactions, turning simple molecules into complex organic compounds under the right circumstances. It's as if the universe itself has engineered the perfect delivery system for life's raw materials. But here's where the theory gets provocative. If dust can carry and preserve organic molecules, could it also organize them? Recent studies of Antarctic ice cores reveal dust particles with layered organic coatings, resembling microscopic onion skins of alternating compounds. Under high-resolution imaging, some grains show repeating molecular motif sequences that look less like random chemistry and more like structured data. Picture a barcode where each line isn't black and white, but a specific arrangement of carbon, hydrogen, and oxygen atoms. The implications ripple outward. If life on Earth was seeded by dust carrying not just random organics but prearranged molecular blueprints, it would mean our existence might stem from more than chance. Some researchers speculate that certain dust grains could function like biological keys, designed to trigger specific chemical cascades when they encounter the right environment, a warm tidal pool, a hydrothermal vent, or the icy crust of a moon. The idea isn't entirely without precedent. Viruses operate similarly on Earth, injecting genetic instructions into cells to hijack their machinery. Cosmic dust could be nature's or someone else's version of this process, scaled up to interstellar proportions. Of course, skepticism is warranted. The universe is vast and complexity doesn't automatically imply design. Yet as detection methods improve, the anomalies pile up. Spectroscopic analyses of distant nebulae reveal organic molecules forming in regions where conventional chemistry says they shouldn't. Lab experiments demonstrate that dust irradiated by starlight can self-assemble into lipid-like membranes, the precursors to cellular walls. Each discovery edges us closer to a paradigm where cosmic dust isn't just a bystander in the story of life, but an active participant or even an author. The next time you wipe dust off a windowsill, consider this. Mixed in with ordinary terrestrial particles might be specks older than the sun, carrying echoes of a message written not in words or symbols, but in the very language of life. Whether that message is nature's poetry or something more deliberate remains one of science's greatest unsolved riddles. In 2004, NASA's Stardust spacecraft did something unprecedented. It reached out and grabbed dust from the tail of a comet, bringing minuscule pieces of the cosmos back to Earth. The mission's goal was simple: capture pristine particles from Wild 2, a comet thought to contain material unchanged since the solar system's birth. But what scientists found when they opened the sample canister shattered expectations. Instead of just ancient minerals, they discovered a menagerie of bizarre particles, some so strange they sparked debates that still rage today. Among the usual suspects, silicate grains and carbon compounds were tiny structures with eerily geometric shapes, including one dubbed the Extraterrestrial snowflake, a crystalline arrangement so intricate it looked almost manufactured. Then there were the mystery particles. These weren't just unusual, they defied classification. One grain, analyzed under a microscope, contained magnesium olivine in a layered pattern resembling circuit boards with alternating sheets of organic and inorganic material. Another showed isotopic ratios of oxygen and nitrogen so skewed they couldn't be explained by known stellar processes. The team even found metallic microspheres with surface patterns resembling fractal designs, repeating shapes that mathematicians associate with information encoding. To some researchers, these weren't just cosmic oddities. They were potential hallmarks of engineering, tiny artifacts that carried whispers of intention. The most controversial discovery came from the aerogel collectors, the ultra-light material used to trap dust without damaging it. Embedded in the gel were tracks left by high-speed particles, some zigzagging in ways that suggested abrupt changes in density or composition. But one track stood out, a narrow, corkscrew-like path ending in a grain rich in unusual alloys. Spectral analysis revealed it contained elements like hafnium and tungsten in ratios never seen in natural space debris. These metals, often used in human technology for their durability and conductivity, raised eyebrows. Could this have been a random fluke, or was it evidence of something more deliberate? Mainstream science urges caution, pointing out that nature is full of complex structures we don't yet understand. Yet the Stardust findings keep resurfacing in conferences about astrobiology and SETI. Why? Because the mission proved something revolutionary. Cosmic dust isn't uniform. It's a mosaic of the universe's history, carrying wild diversity in its microscopic grains. If just one of those anomalies turned out to be artificial, the implications would rewrite textbooks. The Stardust samples now sit in labs, scrutinized by machines that didn't exist when the mission launched. With every new analysis, we peel back another layer of the mystery, one speck of dust at a time. If cosmic dust holds messages from distant civilizations, the first challenge isn't just finding them, it's figuring out how to read them. Language as we know it relies on shared rules, alphabet, syntax, the dance of symbols and sounds. But what happens when the letters aren't etched on paper or broadcast as radio waves, but arranged in the atomic structure of a grain smaller than a human cell. This is where linguists and cryptographers step into the cosmic fray, armed not with dictionaries but with electron microscopes and spectral analysis. Their goal, to distinguish random noise from deliberate design in the universe's tiniest artifacts. Take the concept of isotopologues, molecules that differ only in their isotopic composition. To a chemist, they're natural variations, but to a linguist analyzing cosmic dust, they could be something else entirely. Imagine finding a grain where carbon-13 atoms appear at precise intervals, like beats in a musical measure, while carbon-12 fills the spaces between. Natural processes rarely produce such regularity, but an intelligent sender might use these subtle variations as a code. Researchers at the SETI Institute have proposed treating isotopic ratios like phonetic alphabets, where each variant represents a discrete unit of information. It's akin to translating Morse code written not in dots and dashes, but in the very fabric of matter. Then there's the problem of syntax. Human languages follow grammatical rules, but an alien system might rely on multidimensional patterns invisible to linear analysis. Cryptographers working with dust samples search for recursive structures repeating motifs at different scales, like a fractal where each layer reveals deeper complexity. The discovery of silicate grains with nested crystalline geometries, where each shell mirrors the last but with slight variations, has sparked speculation. Could these be cosmic equivalents of nested clauses, where meaning builds upon itself like Russian dolls of information? The challenge intensifies when considering non-human cognition. Our languages evolved to describe earthly experiences, time, space, tangible objects. A species communicating through dust might think in entirely different frameworks, perhaps using quantum probabilities or thermodynamic states as their vocabulary. Some theorists suggest that certain dust anomalies, particles that exhibit unexpected quantum coherence or heat dissipation patterns, could be physical manifestations of concepts we lack words for. Deciphering them would require more than linguistics. It would demand a new science blending physics, semiotics, and pure imagination. Cultural context adds another layer. Just as human languages borrow metaphors from nature, the river of time, the fire of passion, an alien message might draw on cosmic phenomena we've yet to understand. A sequence of iron isotopes could reference supernova nucleosynthesis, while a cluster of rare Earth elements might point to planetary formation. Without shared experiences, even a clearly artificial pattern risks becoming a Rosetta Stone with no translation key. That's why projects like METI International now collaborate with anthropologists, studying how isolated human cultures developed writing systems, hoping to find universal principles that might apply beyond Earth. One promising avenue draws from information theory, the mathematical study of data encoding. Natural cosmic processes generate randomness, while intelligence tends toward compression-efficient, non-random arrangements. By applying algorithms that measure informational density, scientists can flag dust grains that deviate from expected entropy levels. A team at the University of California recently analyzed micrometeorites using these methods and found several with molecular structures exhibiting Zipf's law, a linguistic pattern where the frequency of any word is inversely proportional to its rank, a hallmark of human languages. The odds of this occurring naturally, less than 1 in a million, yet for all our tools, the greatest obstacle may be our own biases. Early attempts to decipher Egyptian hieroglyphs stalled because scholars assumed they were purely symbolic, not realizing they also represented sounds. Similarly, we risk misreading cosmic messages by projecting human expectations onto them. The breakthrough might come not from forcing dust patterns into familiar frameworks, but from letting them redefine what communication can be. After all, if the universe is speaking to us through stardust, it's using a vocabulary forged over billions of years, and we're just learning our first words. Dark matter, the invisible, enigmatic substance that makes up most of the universe's mass, has long baffled scientists. It doesn't emit light, absorb radiation, or interact with ordinary matter in any way we can easily detect. Yet its gravitational pull shapes galaxies, bending the very fabric of space. Now, imagine if this mysterious force isn't just a passive backdrop to the cosmos, but an active participant in the cosmic dust mystery. Could dark matter somehow influence or even carry the very messages we've been searching for in those minuscule interstellar particles? The idea might seem far-fetched, but when you peel back the layers, the connection isn't as implausible as it sounds. For starters, consider how dark matter behaves. While it doesn't collide with ordinary matter, its gravitational effects are undeniable. Vast halos of dark matter envelop galaxies, warping the paths of stars and dust alike. Some theorists suggest that dark matter could act as a kind of cosmic scaffolding, guiding the distribution of dust clouds across interstellar space. If that's true, then the dust grains we've been studying might not be drifting randomly. They could be channeled along invisible dark matter currents, arranged in patterns we've yet to recognize. Picture a river flowing through a canyon. The water follows the contours of the land, just as dust might follow the unseen contours of dark matter's grip. Then there's the tantalizing possibility that dark matter itself could encode information. We know so little about its true nature that some physicists speculate it might interact in ways beyond gravity, through hypothetical dark photons or other exotic particles. If dark matter has any form of subtle interaction with ordinary matter, even on quantum scales, it could theoretically imprint data onto dust grains as they pass through its influence. Think of it like a cosmic etch-a-sketch where dark matter's invisible hand writes on dust by altering its atomic structure in undetectable ways. Scientists have already proposed that certain anomalies in cosmic dust, unexplained isotopic shifts or strange quantum behaviors, could stem from interactions with dark matter particles we haven't discovered yet. The most radical hypothesis takes this even further. What if dark matter isn't just a medium but a messenger? Some researchers toy with the idea that advanced civilizations might have learned to manipulate dark matter, using it as a carrier for information. Unlike cosmic dust, which can be eroded or destroyed, dark matter is practically eternal. A message encoded in its fabric would survive supernova, black holes, and the heat death of the universe. It's the ultimate time capsule, impervious to the ravages of time. If such a signal exists, decoding it would require entirely new physics, tools that let us see the invisible. Skeptics, of course, argue this veers into pure speculation. Dark matter's existence is still inferred, not confirmed, and its properties remain a puzzle. But history shows that the wildest ideas often spark the most profound discoveries. The notion that cosmic dust might carry alien messages once seemed equally outlandish, yet here we are, analyzing microscopic grains for signs of design. The universe has a habit of being stranger than we imagine. Whether dark matter plays a role in this cosmic conversation or not, the mere act of wondering forces us to look deeper, question harder, and reconsider what we think we know about the silent, invisible forces shaping our reality. And that's the beauty of the unknown. It doesn't just challenge our tools, it challenges our minds. Every time we confront a mystery like dark matter or cosmic dust, we're not just searching for answers. We're learning how to ask better questions. When Oumuamua streaked through our solar system in 2017, it shattered expectations. This bizarre, cigar-shaped object wasn't just the first known interstellar visitor. It defied every rule of conventional astronomy. Unlike typical comets, it lacked a visible dust tail. Instead of tumbling chaotically, its movement suggested an oddly streamlined shape, and most puzzling of all, its trajectory couldn't be fully explained by gravity alone, as if something unseen was nudging it along. While debates raged over whether Oumuamua was a weirdly shaped rock or something more exotic, a quieter question lingered in labs and observatories. If this interstellar wanderer left no obvious dust trail, could its microscopic debris still hold clues to its true nature, or even signs of something deliberate? Dust might seem like an afterthought when studying such dramatic visitors, but it's often the smallest fragments that tell the biggest stories. When asteroids or comets enter Earth's atmosphere, they leave behind minuscule particles suspended in the upper air currents, invisible to the eye but detectable with sensitive instruments. These meteoritic dust grains act like cosmic breadcrumbs, preserving chemical and structural details about their parent bodies. For Oumuamua, which never came close enough to Earth to shed detectable debris, researchers had to get creative. Telescopes trained on its path searched for micron-sized particles it might have shed during its journey, while teams analyzed older data from atmospheric dust collectors. The goal: to find any grain with isotopic ratios or crystalline structures matching interstellar space, or stranger still, patterns hinting at artificial origins. One tantalizing lead comes from a meteor that exploded over Papua New Guinea in 2014. Later analysis suggested it, too, originated beyond our solar system, making it the first known interstellar meteor to collide with Earth. When a team from Harvard retrieved fragments from the ocean floor, they found tiny metallic spherules unlike anything in our solar system's catalog. Some contained alloys of beryllium, lanthanum, and uranium, a combination so rare in nature that the researchers called it anomalous. Even more intriguing were the spheral surfaces, which under high magnification revealed etched patterns resembling microscopic circuitry. Mainstream science urges caution, noting that extreme heat and pressure during atmospheric entry can create bizarre but natural formations. Yet the parallels to lab-engineered nanomaterials are hard to ignore. This raises a provocative possibility. If interstellar objects like Oumuamua or the Papua New Guinea meteor were artificial, perhaps derelict probes or fragments of alien technology, their dust might carry encoded signatures. Advanced civilizations wouldn't necessarily build monolithic structures. They might disperse countless tiny sensors or message carriers designed to drift between stars. Dust grains could function like cosmic USB drives, storing data in atomic arrangements or quantum states. Labs analyzing such particles now employ techniques from quantum microscopy to AI-driven pattern recognition, searching for anything that breaks the rules of natural chemistry. A single grain with isotopically layered metals or unnatural crystal symmetries could rewrite history. Critics argue that interstellar space is full of weird chemistry we don't yet understand, and labeling anomalies as artificial risks repeating the Martian meteorite debacle of the 90s, when purported fossilized bacteria turned out to be geological quirks. But proponents counter that dismissing outliers outright stifles discovery. After all, the first known interstellar meteors weren't identified until recently. How many more slipped past unnoticed? With upcoming projects like the Vera Rubin Observatory set to detect dozens more interstellar visitors, we're on the verge of a new era. Each one could be a rock. Or it could be a message in a bottle, one where the bottle is a speck of dust, and the message is written in the language of the universe itself. The next time you hear about a meteor lighting up the sky, consider this. Mixed in with the fire and fury could be remnants of a world beyond our solar system, carrying whispers from across the galaxy. Whether natural or engineered, these cosmic travelers remind us that the universe is far stranger and far more connected than we ever imagined. Ancient texts and sacred scriptures often speak in metaphors. But what if some of those poetic descriptions weren't just spiritual allegories, but eyewitness accounts of something far more tangible? Take the Hindu Vedas, for example, where the Rig Veda describes Vishnu Kana, particles so fine they're invisible to the naked eye, yet carry the breath of creation. These grains, said to rain from the heavens, were believed to hold the blueprints of life itself. modern science now knows that cosmic dust does in fact contain prebiotic molecules like amino acids. Could the Vedas have been recording something real, mistaking advanced cosmic phenomena for divine intervention? The ancient Egyptians took this idea further. Their Book of the Dead speaks of golden powder falling from the sky, a substance priests collected to anoint the pharaohs, claiming it granted divine wisdom. Recent analysis of Egyptian temple relics revealed trace amounts of iridium and platinum metals, rare on Earth but abundant in micrometeorites. Were these gifts from the gods actually interstellar dust particles, revered without understanding their extraterrestrial origins? Even their myths of Osiris, the god resurrected from scattered fragments, echo the way cosmic dust coalesces into new forms across millennia. Then there's the Bible's book of Daniel, where the prophet describes a vision of fiery dust descending from the heavens, carrying voices too faint to comprehend. Early theologians dismissed this as symbolic, but the description aligns eerily with modern accounts of meteoric dust storms, events where charged particles interact with Earth's atmosphere, producing eerie sounds known as electrophonic meteors. Indigenous Australian cultures, too, have dreamtime stories of star sand whispering ancestral knowledge, a tradition that persisted for generations before scientists confirmed the presence of presolar grains in Australia's desert sands. But the most striking parallel comes from the Tibetan Buddhist text, the Bardo Thodol. It describes a post-death realm where the soul encounters countless specks of light, each containing a message that must be deciphered to achieve enlightenment. The text meticulously details how these particles rearrange themselves into geometric patterns when observed with focused intention, a process startlingly similar to quantum experiments where observation affects particle behavior. Could this be a cultural memory of encountering dust engineered to respond to consciousness? Skeptics argue that humans have always projected meaning onto natural phenomena, from thunder as divine wrath to eclipses as omens. Yet the consistency across isolated cultures is hard to ignore. The Dogon people of Mali, who knew of Sirius's invisible companion star long before telescopes, also spoke of its dust veil transmitting ancestral knowledge. The Popol Vuh of the Maya describes creator gods mixing star mud to fashion humanity. Even medieval alchemists sought the primordial ash they believed held cosmic secrets, a quest that mirrors modern scientists analyzing dust for clues to life's origins. What unites these accounts is the recurring theme of transformation, dust as a medium between realms carrying hidden knowledge. Whether by divine providence or ancient contact with something beyond our understanding, these texts suggest humanity has always sensed there's more to cosmic dust than meets the eye. The next time you read an ancient myth about heavenly particles, ask yourself, were our ancestors describing encounters with the universe's oldest messaging system long before science gave us the tools to see it? Humanity is already experimenting with the idea of turning atoms into data carriers. Our most advanced computer chips now store information in structures just a few nanometers wide. So why wouldn't a civilization thousands or millions of years ahead of us take this concept further, engineering dust itself as the ultimate interstellar hard drive? This isn't just speculative futurism, it's a theory gaining traction among astrobiologists and nanotechnologists alike. Picture a fleet of artificial dust grains, each one a microscopic marvel, programmed to drift for eons with messages encoded not in binary but in atomic arrangements. The key lies in scale. A single grain of cosmic dust may seem insignificant, but at the nanoscale, it becomes a vast landscape where trillions of atoms can be precisely arranged. Advanced civilizations could manipulate these particles using molecular manufacturing, embedding data in ways that defy natural origins. Imagine dust grains with crystalline lattices where specific atoms are swapped like letters in an alphabet, silicon replaced by phosphorus at exact intervals, or layers of graphene patterned like a barcode. These engineered anomalies would stand out starkly against the randomness of natural space debris, screaming artificiality to any civilization with the tools to notice. Consider the work being done right now in quantum dots, human-made nanoparticles that can store and transmit information at the atomic level. Scientists have already demonstrated how these structures can hold data in the spin states of electrons or the positions of individual dopant atoms. Scale this up to cosmic proportions, and you have a scenario where a civilization might scatter billions of these engineered particles across the galaxy like cosmic confetti, each one a fragment of a larger message. Unlike radio transmissions that degrade over distance, these nanoscale messengers would persist, surviving supernova and black holes to deliver their payloads across geological time. The real brilliance of this method lies in redundancy. A civilization could program these particles to self-replicate using raw materials found in interstellar space, ensuring their message spreads exponentially. Some researchers speculate that certain types of cosmic dust, like the enigmatic GEMS particles found in cometary samples, might exhibit properties too orderly for natural formation. These glassy spherules, rich in metals and silicates, show layered nanostructures resembling human-designed data storage systems. Could they be ancient, degraded remnants of a technology so advanced it blurs the line between engineering and natural physics? Even more mind-bending is the idea that these particles might not just carry information, they could execute it. Programmable matter, a field in its infancy on Earth, explores materials that can change their properties on demand. Applied to interstellar dust, this could mean particles that rearrange themselves when triggered by starlight, magnetic fields, or even quantum entanglement. A cloud of such dust might initially appear inert until some universal password, a specific wavelength of light or energy pulse, activates its hidden functions, causing it to assemble into larger structures or emit coordinated signals. The wow signal might not have been a transmission at all, but the activation of a dormant dust cloud drifting through our solar system. Critics argue that space is so vast, even purposeful engineering would drown in the noise of natural particles. But proponents counter that we're thinking too small. A sufficiently advanced civilization wouldn't just scatter dust randomly, they'd design it to be found. Certain isotopes or molecular chirality could act as universal signatures, like a return address stamped on every grain. Others suggest dust might use quantum entanglement to phone home when intercepted, alerting its creators that it had been found. The more we study cosmic dust, the more we uncover anomalies that resist conventional explanation. From grains with isotopic ratios unlike anything in our solar system to metallic microspheres with surface etchings resembling circuitry. Perhaps the most provocative question isn't whether such technology exists, but whether we'd recognize it if we saw it. Our tools for analyzing dust are still primitive compared to what might be possible. A civilization capable of engineering matter at this level might use physics we haven't even discovered yet, turning dust into something far more sophisticated than we can currently conceive. Until we develop the means to probe deeper, atom by atom, quantum state by quantum state, the truth might remain hidden in plain sight, floating silently among the stars. The next breakthrough in the search for extraterrestrial intelligence might not come from a radio telescope, but from a nanotechnology lab. As we push the boundaries of what's possible at the smallest scales, we inch closer to understanding how the universe might have been speaking to us all along, not in waves or words, but in the language of atoms themselves. Somewhere in the vast stretches of the cosmos, drifting between stars and galaxies, lies what could be the most enduring library ever conceived, not built from stone or paper, but from the very fabric of space itself, cosmic dust. Imagine a civilization so advanced, so determined to etch its story into eternity, that it transforms the smallest fragments of matter into timeless archives. These wouldn't be books or hard drives, but microscopic grains engineered to outlast stars, carrying the collective knowledge of a species that may have vanished billions of years ago. Unlike monuments that crumble or signals that fade, dust is eternal, scattered across the universe like pages torn from a cosmic manuscript, waiting for the right reader to piece them together. The concept hinges on one extraordinary property of dust, its longevity. While civilizations rise and fall, while planets are born and consumed by dying stars, cosmic dust persists. It rides stellar winds, survives supernova, and drifts untouched through the voids between galaxies. If an ancient civilization wanted to ensure their history wasn't lost to time, encoding it into dust would be the ultimate insurance policy. Each grain could function as a node in a vast decentralized archive, with information stored not in binary code but in the precise arrangement of atoms. Isotope ratios could serve as letters, molecular structures as syntax, and crystalline lattices as the parchment. Unlike our fragile digital storage, which degrades within decades, this atomic writing could endure for eons. But what would such a library contain? The possibilities are as boundless as the universe itself. One grain might hold the genetic blueprint of an extinct alien species, preserved in layered organic molecules. Another could carry star maps pointing to habitable worlds or long-dead civilizations. Some might even store philosophical treatises or art, not as pixels or text, but as quantum vibrations or chiral patterns in amino acids. The beauty of this system is its scalability. A single speck might hold a haiku's worth of data, while a cluster could encode entire encyclopedias when read in sequence. The real challenge lies in retrieval. Unlike a book where pages follow a set order, cosmic dust is scattered chaotically across light years. Deciphering a message this fragmented would require more than just translation. It would demand reconstruction. Think of it like assembling a jigsaw puzzle where the pieces are scattered across continents, and the picture changes depending on how you arrange them. Advanced civilizations might have anticipated this, embedding redundancy or error-correcting algorithms into the dust itself. Certain isotopes could act as metadata, guiding the reader to adjacent grains or flagging critical sequences. Others might function like cosmic QR codes, triggering assembly instructions when scanned by sufficiently advanced technology. Skeptics argue that space is already full of naturally complex dust, and distinguishing an artificial archive from random debris would be impossible. But proponents counter that nature follows statistical rules while intelligence leaves fingerprints. A grain with platinum atoms arranged in a Fibonacci spiral, or carbon isotopes distributed like prime numbers, would stand out against the backdrop of cosmic chaos. Labs today are already developing atomic-scale probes capable of detecting such anomalies. Projects like Breakthrough Starshot, which aims to send nanocrafts to nearby stars, could one day include dust analyzers designed to sniff out these celestial libraries. What's most thrilling isn't just the idea that we might one day read these archives, it's the realization that we could be walking through them right now. Every breath you take contains atoms forged in distant supernova. Every sunbeam carries stardust older than Earth. Somewhere in that endless shower of cosmic particles might be a message from a civilization that gazed at their night sky and wondered, just as we do, if they were alone in the universe. Their words wouldn't arrive as radio waves or laser pulses, but as silent, patient motes waiting for the day someone or something would think to look closely enough to listen. And that's the profound irony of this search. The greatest library in existence might not be hidden in some distant nebula. It could be right here, mingling with the dust on your windowsill or floating in the air around you, an archive written in atoms, invisible until the moment we learn how to see it. Detecting patterns in cosmic dust isn't like tuning a radio to a clear signal. It's more like trying to overhear a whisper in a hurricane. The first hurdle is sheer scale. Every year, Earth sweeps up tens of thousands of tons of interstellar dust, but only a minuscule fraction of those particles might carry anything unusual. Sifting through them is the ultimate needle in a haystack challenge, compounded by the fact that these grains are smaller than a fraction of a human hair. Even with cutting-edge electron microscopes and mass spectrometers, distinguishing a deliberate pattern from natural randomness demands precision bordering on the impossible. Take isotopic ratios, one of the most promising avenues for spotting artificial signatures. Normally, elements like carbon or oxygen have predictable variance based on cosmic abundance. But if a dust grain showed carbon-13 arranged in a perfect geometric sequence, or oxygen-18 clustered in prime number groupings, it could hint at design. The problem: natural processes occasionally produce oddities too. Volcanic eruptions, cosmic ray bombardment, or even rare stellar nucleosynthesis can create isotopic quirks that mimic intentionality. Without a universal benchmark for what's unnatural, even the most tantalizing anomalies risk being dismissed as cosmic noise. Then there's the issue of degradation. Cosmic dust isn't pristine by the time it reaches us. These particles endure radiation, collisions, and atmospheric entry, which can scramble their atomic structures. A grain that might have originally held a crisp, engineered pattern could arrive warped or fragmented, like a faded parchment recovered from an ancient shipwreck. Labs use techniques like atom probe tomography to reconstruct damaged grains atom by atom, but the process is painstaking and gaps in the data leave room for doubt. Imagine finding a shattered clay tablet with half the hieroglyphs missing. You might recognize it as writing, but the message could be forever lost. Complicating matters further is the question of context. Human languages rely on shared references. We understand tree because we've seen one. An alien message might use metaphors based on phenomena we've never witnessed, like quantum fluctuations in neutron stars or the thermodynamics of dark matter clouds. Without that shared vocabulary, even a blatantly artificial pattern could resemble abstract art, striking but indecipherable. Some researchers propose looking for mathematical universals, prime numbers, fractals, or geometric constants as a Rosetta Stone. But what if the senders thought in dimensions beyond our comprehension? A three-dimensional language might look like chaos when flattened into our tools' two-dimensional scans. Technology adds another layer of limitation. Today's finest microscopes can resolve individual atoms, but they're destructive. Analyzing a grain might vaporize it in the process, leaving no chance for re-examination. Non-invasive methods like X-ray diffraction preserve samples but lack the resolution to spot nanoscale patterns. It's like trying to read a book by weighing it. You might detect its presence but not its meaning. Breakthroughs in quantum sensing could one day let us probe dust grains without disturbing them, harnessing entangled particles to feel their structures indirectly. Until then, we're essentially reconstructing fire from the ashes, hoping we haven't missed the spark. Perhaps the most profound challenge is bias, both in what we look for and how we interpret it. Humanity's search for extraterrestrial intelligence has historically been shaped by our own technological milestones. First radio, then lasers, now dust. But what if advanced civilizations communicate through mediums we haven't even conceived? There's also the risk of seeing what we want to see. The history of science is littered with false positives, from the canals of Mars to the infamous wow signal. Without rigorous frameworks to distinguish wishful thinking from genuine discovery, even the most meticulous dust analysis could lead us down rabbit holes of our own making. Yet these obstacles aren't dead ends, they're invitations to innovate. Each hurdle forces us to refine our tools, question our assumptions, and expand the boundaries of what we consider possible. The very act of grappling with these challenges sharpens our ability to listen to the universe, whether it's speaking through dust, light, or some medium we've yet to imagine. And if we ever do crack the code, it won't just be a message we uncover, it'll be proof that persistence, creativity, and humility are the truest instruments of discovery. Discovering an alien message in cosmic dust wouldn't just rewrite science textbooks, it would force humanity to confront ethical dilemmas we've never faced before. Who gets to speak for Earth if we're suddenly part of an interstellar conversation? The moment we confirm that a speck of dust carries intentional design, we're no longer passive observers of the cosmos. We become participants in a dialogue that could span galaxies and epochs, with consequences far beyond academic curiosity. One immediate concern revolves around ownership and control. Unlike radio signals that belong to no one, physical dust particles can be collected, hoarded, or weaponized. Imagine a scenario where a corporation patents decoding methods for alien messages, locking humanity's first contact behind intellectual property laws. Or worse, governments classifying discoveries as national security secrets, denying the world access to knowledge that fundamentally alters our place in the universe. The 1967 Outer Space Treaty prohibits nations from claiming celestial bodies, but it says nothing about cosmic dust, a legal gray zone that could spark conflicts over who owns these microscopic messengers. Then there's the question of reply protocols. SETI current guidelines advise international consensus before responding to any extraterrestrial signal, but dust complicates this. If messages are embedded in particles raining down globally, how do we coordinate a unified human response? A single rogue actor, whether a billionaire with a lab or a hacker collective, could theoretically engineer reply particles and launch them into space without oversight. The stakes are astronomical. An ill-considered response might reveal Earth's location to hostile entities or accidentally trigger dormant dust-based systems we don't understand. Ancient myths warn of Pandora's boxes. Cosmic dust could be the literal version. The ethical labyrinth deepens when considering cultural contamination. Human history is rife with disastrous first contacts between civilizations at unequal technological levels. If we're the less advanced party in this exchange, decoding alien dust might expose us to ideas or technologies we're unprepared to handle. Philosophers like Nick Bostrom argue that advanced knowledge could act as an information hazard, destabilizing societies or accelerating existential risks. A single grain might contain blueprints for self-replicating nanotechnology or revelations about cosmic threats, information that could uplift or shatter civilizations. But the most profound dilemma is ontological. Confirmation that we're not alone reshapes everything from religion to identity. Indigenous cosmologies that already view humanity as part of a living cosmos might adapt fluidly, while rigid doctrinal systems could fracture under the weight of extraterrestrial intelligence. The discovery might also force us to reconsider our definition of life itself. If dust particles are engineered carriers rather than natural formations, does that make them alive? Are we dealing with artifacts or something far stranger, a form of intelligence that transcends biology as we know it? Amid these uncertainties, one principle emerges as vital: humility. The universe has likely been encoding messages in dust for billions of years before humans existed. Whatever we find, we're not the authors of this story. We're latecomers learning to read a language written long before our planet formed. That realization alone could be the most transformative message cosmic dust carries, a reminder that wisdom begins with knowing how much we don't know. The next decade promises a revolution in our ability to study cosmic dust, thanks to a fleet of advanced space missions poised to turn their instruments toward these microscopic enigmas. Leading the charge is NASA's James Webb Space Telescope, which has already begun probing the chemical makeup of distant dust clouds with unprecedented precision. Unlike Hubble, which primarily observes visible light, Webb's infrared eyes can peer through dense veils of interstellar dust, analyzing their composition molecule by molecule. But the real game-changer lies in its spectrograph's tools so sensitive they can detect isotopic ratios in dust grains thousands of light years away. Scientists are particularly eager to scan regions like the Orion Nebula, where young star systems are shrouded in dust rich with organic compounds. If any grains there exhibit unnatural isotopic patterns or crystalline symmetries, Webb might be the first to spot them. Meanwhile, the European Space Agency's upcoming Comet Interceptor mission takes a more hands-on approach. Scheduled for launch in 2029, this ambitious project will park a spacecraft at a gravitational sweet spot between Earth and the Sun, lying in wait for an undiscovered interstellar object or even a rogue comet to swing by. Once a target is identified, the probe will deploy multiple smaller craft to surround it, capturing dust particles directly from its tail. The mission's ultra-clean sample chambers are designed to prevent contamination, ensuring any anomalies found can't be dismissed as earthly interference. Given that interstellar objects like Oumuamua and the Papua New Guinea meteor have already delivered bizarre dust signatures, the Comet Interceptor could provide the first pristine samples of potential message-bearing particles. Not to be outdone, Japan's Destiny Plus mission is gearing up to chase down the enigmatic asteroid Phaethon, a bizarre blue-tinged body that spews dust clouds resembling comet tails. Phaethon's debris trail, known as the Geminid meteor shower, rains hundreds of tons of particles on Earth annually, some of which have shown unusual metal-rich compositions. Destiny Plus will fly through Phaethon's dust plume in 2031, analyzing it in real time with onboard mass spectrometers. The mission's lead scientists openly speculate that if any dust grains carry intentional patterning, this oddball asteroid might be the perfect place to look. But the most audacious project on the horizon is Breakthrough Starshot's plan to send gram-scale nanoprobes to Alpha Centauri. While their primary goal is to photograph exoplanets, the probe's onboard sensors could also sample interstellar dust during their 20-year journey. These devices, no larger than a postage stamp, will carry atomic force microscopes capable of mapping individual atoms in encountered particles. Given that Alpha Centauri's system is older than ours, any dust found there would have had more time to accumulate anomalies or messages. Starshot's founder, Yuri Milner, has even mused about programming the probes to search for technosignatures in dust, a nod to the theory that advanced civilizations might use particles as cosmic data packets. Closer to home, private initiatives are joining the hunt. Companies like Astroforge are developing orbital dust analyzers to mine asteroids, but their tech could easily be repurposed to scan for engineered grains. Meanwhile, university labs are upgrading atmospheric sampling stations across the globe, from the peaks of the Andes to the ice sheets of Antarctica, creating a planetary net to catch and scrutinize incoming interstellar dust. What makes this new generation of missions so exciting isn't just their technology, it's their mindset. For the first time, projects are being designed with the explicit possibility that dust might not be passive debris. Whether they uncover deliberate patterns or merely push the boundaries of natural physics, one thing is certain: the universe's tiniest particles are about to take center stage in humanity's greatest detective story. And with every speck analyzed, we inch closer to answering the haunting question of whether we've been surrounded by cosmic whispers all along. While the idea of cosmic dust carrying alien messages sparks the imagination, science demands we consider more grounded explanations before leaping to extraterrestrial conclusions. Many of the peculiar patterns and anomalies found in interstellar particles could stem from entirely natural processes we simply don't fully understand yet. Take the case of isotopic ratios, those seemingly deliberate arrangements of atomic variants that some researchers suggest could encode information. Stellar nucleosynthesis, the process by which stars forge elements, can produce unexpected isotope distributions under extreme conditions. Supernova, neutron star collisions, and even the turbulent environments around black holes generate energies so intense they twist nuclear physics into unfamiliar shapes. A dust grain forged in these cosmic infernos might carry chemical quirks that look engineered to our eyes, but are really just scars from its violent birth. Then there's the puzzle of crystalline structures. Certain cosmic dust grains exhibit geometric perfection, symmetric lattices, or layered formations that seem too precise for random chance. Yet nature has a knack for self-assembly. Snowflakes on Earth form intricate hexagonal patterns without any intelligent guidance, driven purely by the physics of water molecules in freezing air. In the depths of space, similar processes could shape dust grains as they cool in the aftermath of stellar explosions. Laboratory experiments have recreated these conditions, showing how silicates and metals can crystallize into fractal-like arrangements when exposed to the vacuum and temperature gradients of space. What looks like a meticulously crafted message might just be the universe's innate tendency toward order emerging from chaos. Instrument error and contamination loom as even more mundane but critical explanations. Analyzing nanometer-scale particles pushes our technology to its limits. A single speck of terrestrial dust sneaking into a sample chamber, a vibration during microscope imaging, or even cosmic rays striking a detector can produce false signals. The infamous alien microbe claims surrounding the Mars meteorite LH84001 serve as a cautionary tale. Initially hailed as proof of extraterrestrial life due to its microscopic structures, further study revealed they were likely formed by mundane geological processes. Cosmic dust research risks similar pitfalls if anomalies aren't scrutinized with ruthless skepticism. Perhaps the most compelling counterargument comes from sheer statistics. Space contains an almost unimaginable number of dust particles, countless trillions drifting between stars. Even if natural processes produce strange patterns only once in a billion times, the law of large numbers guarantees we'll find countless oddballs. It's like shuffling a deck of cards endlessly. Eventually, you'll get a hand that seems impossibly ordered. Without context or repetition, singling out a few peculiar grains as evidence of design risks falling for the Texas sharpshooter fallacy, drawing bullseyes around random bullet holes after the fact. This isn't to dismiss the cosmic dust code theory entirely, but to underscore that extraordinary claims demand extraordinary evidence. The universe is under no obligation to conform to our expectations, and its natural creativity often outstrips our imagination. Before we declare a speck of dust an alien missive, we must exhaust every possible explanation rooted in known physics and chemistry. After all, uncovering the truth, whether it's a message from the stars or a new natural phenomenon, is what science is all about. The beauty lies in the search itself, where every anomaly, whether mundane or miraculous, teaches us something new about the cosmos we call home. The moment the theory of encoded cosmic dust entered the public consciousness, it ignited a firestorm of speculation that spread far beyond academic circles. Online forums like Reddit's r/conspiracy and r/high strangeness lit up with threads dissecting everything from microscopic images of meteorite fragments to grainy YouTube videos claiming to show alien dust collected from rooftops. Some users posted magnified photos of ordinary household dust, insisting the jagged shapes were tiny hieroglyphs or circuitry, a modern-day pareidolia where people see faces in clouds, but this time they're seeing messages in debris. The hashtag #DustCodes trended on Twitter after a viral tweet juxtaposed a scientist's diagram of a dust grain's layered structure with an ancient Sumerian cuneiform tablet, asking, "What if we've been mistaking archaeology for astronomy all along?" Documentaries seized on the mystery, blending fact with sensationalism. A popular Netflix series devoted an entire episode to the idea, interviewing researchers who cautiously entertain the possibility of dust-based communication, only to cut to dramatic reenactments of government whistleblowers describing secret labs where anomalous particles were stored in vaults. The episode's climax showed a slow-motion shot of falling dust set to ominous music, implying the audience was watching the universe's oldest surveillance system at work. Meanwhile, YouTube channels specializing in fringe theories ran with titles like "They're hiding the cosmic alphabet in your air filter," racking up millions of views with montages of lab equipment and ominous voiceovers warning that the truth is floating right under our noses. Conspiracy theories flourished in this fertile ground. One persistent claim insisted that chemtrails, the contrails left by aircraft, were actually dispersing alien messenger dust to manipulate human DNA. Another faction pointed to the discovery of rare earth metals in atmospheric dust samples as proof of a clandestine cosmic postal service, ignoring the more mundane explanation of industrial pollution. The most elaborate theories wove together ancient astronaut lore, suggesting that civilizations like the Egyptians or Maya had decoded dust messages millennia ago, embedding the knowledge into their pyramids and temples. Facebook groups traded blurry microscope images like sacred relics, with some members even mailing envelopes of suspected extraterrestrial dust to universities, demanding analysis. Even the scientific community found itself caught in the whirlwind. Researchers studying cosmic dust reported receiving emails from amateur sleuths claiming to have cracked the code using numerology or AI pattern recognition. One particularly persistent individual flooded astronomy departments with PDFs asserting that dust grains were quantum flash drives containing blueprints for free energy devices, if only scientists would stop suppressing the truth. The irony, of course, was that these very scientists were often the ones pushing for more funding to investigate dust anomalies, only to be drowned out by the noise of well-meaning but misinformed enthusiasts. Yet amid the chaos, something profound emerged. The public's feverish engagement with the idea revealed a deep, almost primal hunger for connection, to the cosmos, to each other, and to the possibility that we're part of something greater. Whether the theories held water or not, they underscored a universal truth. Humanity refuses to accept that the universe is silent. We'd rather sift through dust for whispers than admit we might be alone. And in that refusal, in that relentless searching, we might just find something real, even if it's not the something we expected. So as we reach the end of this cosmic journey, one staggering thought lingers: what if the universe has been communicating with us all along, not through flashing lights or radio waves, but through the silent, drifting poetry of stardust? Every speck that lands on your car windshield or settles on a windowsill might be more than debris. It could be a fragment of an ancient galaxy-spanning language, patiently waiting for us to learn how to read it. The idea challenges everything we thought we knew about contact. Forget towering alien megastructures or booming interstellar broadcasts. The truth might be infinitely subtler, written in atoms instead of words, hidden in plain sight for eons. This isn't just speculation, it's a call to rethink our place in the cosmos. For centuries, we've imagined advanced civilizations signaling us with grand gestures. But what if the most sophisticated messages are also the humblest? Nature thrives on efficiency. A single grain of dust, engineered at the quantum level, could carry more information than all our libraries combined. And unlike fleeting radio signals, these particles persist, traveling for billions of years, surviving supernova and black holes, outliving the civilizations that created them. The universe's oldest mail system might not need mailboxes, just patience. The beauty of this theory lies in its universality. No matter where you are on Earth, you're surrounded by potential messengers from the stars. That shimmer in a sunbeam, those microscopic flecks in a moonbeam, all of them could be part of a conversation that began long before humanity existed. The challenge now is learning to listen not with antennas, but with atom probes and quantum microscopes, tools delicate enough to hear the whispers of the very small. So the next time you gaze at the night sky, remember, the answers we seek might not lie in the distant glimmer of stars, but in the invisible currents between them. The cosmos has a way of hiding its greatest secrets in the most unexpected places, And if we're right, if cosmic dust truly holds the first pages of an interstellar dialogue, then humanity stands on the brink of the ultimate revelation. Not as mere observers of the universe, but as participants in a story written in stardust, waiting for us to turn the next page. Stay curious, keep looking up. And don't forget to glance down too, because the next alien message might already be here, clinging to your sleeve or drifting through the air you breathe. The universe has been speaking all this time. We're only just beginning to understand how to listen.